Okay, in this video we're going to look what we mean by a line of invariant points. It says the matrix minus 3 over 5, minus 4 over 5, minus 4 over 5, 3 over 5 represents a reflection in the line y is equal to minus 2x. Prove that the line y is equal to minus 2x is a line of invariant points. Okay, so what we were saying here, if we have a point and we apply this transformation to it and we get the same point that we started with, and if we do that for a set of points, then we will get a line of invariant points, whereas opposed to before we had a point and maybe it moved somewhere else on the line. In this case it's going to move exactly on itself. That's what we mean by a line of invariant points. Okay, so any point on the line will have coordinates of the form lambda minus 2 lambda. So if it's x, it's minus 2x, so it's got to be lambda minus 2 lambda. Then the image x dash y dash will be the matrix times the coordinates lambda minus 2 lambda, and then we do minus 3/5 times lambda, which gives me minus 3 lambda over 5, and then plus minus 4 over 5 times minus 2 lambda, which gives me plus 8 lambda over 5. Then we do minus 4 over 5 times lambda, which gives me minus 4 lambda over 5, plus 3 over 5 times minus 2 lambda, which will give me minus 6 over 5 lambda. So minus 3 plus 8 will just give me 5 lambda over 5, and then minus 4 minus 10 will give me minus 10 lambda over 5. Obviously the 5's cancel out, we're just left with lambda, and here we get minus 10, 5 goes into that minus 2 times, and 3, so we end up with minus 2 lambda. So we've got back to what we started with, so it doesn't matter what lambda is, we're always going to get back to what we started with. Therefore we can say any point on y is equal to 2x will be mapped onto itself, and these points are known as a line of invariant points. If we go to this applet now that I have, and the applet I will put in the notes of this video, the link to it. Okay, so if we click here, we can see all these points here will be on the same line. V and W are not, they're just the reflection. Okay, and we can move a point here along. You can see every single point there on that line. Okay, and then if we click on this one here, we can see the image of each of those points. So obviously these get reflected, V gets reflected over here and W gets reflected here, but any point on the line will be itself. We can see here, again we should just get some red points here going down like that. Okay, so if we and we can click here, this is the matrix that we started with, this is in decimal form, and there we can see the sort of working. We ended up with lambda minus 2 lambda, we ended up with lambda minus 2 lambda. Okay, so and if we click here we can see the line. If we move we can get rid of the points that we've made. Okay, so we can see here that any point on that line will be reflected onto itself. I hope you've understood, and I thank you very much for watching. Like I said, the link to the GeoGebra applet will be in the notes of this video.